Hello students, welcome to my video class on beta oxidation. Today I am going to just explain how fatty acids, the fat is metabolized, that is it is broken down as to give energy. You all are aware that fat is a high source of energy. Every gram of fat gives about 9 kilocalories of energy. Therefore, it is a major metabolic fuel. Whatever food we eat in excess, whether it is carbohydrate, protein or fat, is all stored as triglycerides in the adipose tissue. Now, when there is requirement for energy, adipose tissue fat will be broken down, which we call it as lipolysis, which gives rise to glycerol and free fatty acid. This glycerol free fatty acid, which is a long molecule, it's a big molecule, cannot travel in the blood as such because most of the fat is broken down in these organs, that is the heart, muscle and the kidney and the liver. Therefore, these organs are doing a lot of work, therefore it uses fat as the fuel. Well, the brain uses a lot of glucose. That's the difference. Now, the free fatty acid that is got from lipolysis is negatively charged big molecule which is hydrophobic. Therefore, it needs to be attached to the albumin to get transported to the site where it has to be degraded. So once it is transported at the site, there is a lipase enzyme which breaks down once again back into the free fatty acid and the albumin is left free. Later, the free fatty acid is taken into the cytosol. Now, the various reactions as how this fatty acid is broken down as to give us energy will be dealt in this video class. So let's start now. Once the fatty acid which has reached the cell, there was a lipase enzyme which hydrolyzed, there were a lot of proteins which hydrolyzed the fatty acid and made it enter into the cell. Once the fatty acid comes into the cell, it comes into the cytosol, it needs to be activated. So we divide this oxidation of fatty acid by beta oxidation to the reactions that happens in the cytosol and the reaction that happens in the mitochondrial matrix. Now, once the fatty acid has reached cytosol, it has to be activated by expenditure of ATP, and there is coenzyme A, which we call it as CoAsh, because you can see that there is a sulfide SH group similar to your OH. So this thiol is acted upon by thiokinase, and what happens to that? Because this is the OH group as good as SH group, this carboxylic group interacts with this and then we get fatty acyl CoA. In order to form this high energy ester bond, there is use of two high energy ATP. Therefore, two high energy phosphate bonds are broken down, giving rise to AMP and 2PI. Now, this fatty acyl CoA, which is formed in the cytosol, is interacted with a molecule called carnitine. This is here carnitine. You can see that there is a nitrogen groups which has 3 methyl groups attached. The structure of carnitine is important. You have a CH2 group on either side for this CH, which is attached to a hydroxyl group. And in the end, you have a carboxylic group. That's how you have to write the structure of carnitine. Now, this is a carrier molecule. Now, this acyl group is loaded onto this carnitine. At which position? At the hydroxyl position here. Here this acyl group is loaded and therefore I get fatty acyl carnitine. Now my big molecule, that is fatty acid, is loaded onto this carnitine which is there in the cytosol, and this carnitine we call it as fatty acyl carnitine, and the CoAsh is left free. It is a ring. So now this fatty acyl carnitine, that is, how was it formed? By the action of carnitine acyl transferase 1. What did it do? It transferred the acyl group onto this position to form fatty acyl carnitine. Why do we call it as 1 and 2? I'll just come to that. Now this fatty acyl carnitine can enter the mitochondria. Now this, as a carrier molecule, it can enter the outer mitochondrial membrane, and here fatty acyl carnitine interacts with coenzyme A and is acted upon carnitine acyl transferase 2, which once again makes fatty acyl CoA, and carnitine is left free. Now this fatty acyl CoA can enter into the mitochondrial matrix. Therefore, the pool of carnitine that is there in the cytosol and the carnitine that gets into the membrane, here once again it transfers it, and there the fatty acyl CoA is released. Now we find that biosynthesis of fatty acids happens in the cytosol, while oxidation, that is catabolic pathway, happens in the mitochondrial matrix. There is completely separation of these compartments. So activation of free fatty acid by the enzyme thiokinase, and then loading onto carnitine. Carnitine getting into the mitochondria, there it interacts with CoAsh by another enzyme, carnitine acyl transferase 2. Free fatty acyl CoA is left and carnitine is released back. This is necessary because the mitochondrial membrane is highly impermeable. Only certain components with the use of carrier molecules only can enter into the inner mitochondrial membrane. You know that mitochondria has two structures. The inner membrane has a lot of invagination, and this portion we call it as the matrix. Now let's start with beta oxidation. As I told you, oxidation is catabolic pathway. We are going to break down this fatty acid into smaller components. There are four main reactions of beta oxidation. There are four enzymatic reactions that happens. So I have written 4 steps of this beta oxidation. In the first step, that is the fatty acyl CoA, I have just taken this expansion. There were many carbons, n number of carbons. I have just shown you the alpha and beta positions. Now this is the carboxylic group, functional group. The next carbon to that is alpha. The other carbon next to that is beta. Now this fatty acyl CoA is acted upon by fatty acyl CoA dehydrogenase. What does a dehydrogenase do? It removes hydrogens. It removes hydrogens means where should it put? It puts to this acceptor molecule, that is FAD+. When I say plus, it is in the oxidized state. You know that? The hydrogens are removed from this fatty acyl CoA by this fatty acyl CoA dehydrogenase and transferred on to FAD, which becomes FADH2. Therefore, it has got reduced. Now, where are the hydrogens removed? one is the hydrogens are removed as to create a trans compound. You can see that one hydrogen from here and one hydrogen is from here. Between the alpha and beta positions are removed. So therefore it creates delta 2 trans-enoyl-CoA, that is this molecule. Now this delta 2 trans-enoyl-CoA is acted upon by enoyl-CoA hydratase. As the name indicates, it is adding a molecule of water. Now at this position OH group adds here, there is a H position, H added on to here. So as a result it forms beta hydroxyacyl-CoA. Now initially there was H and H, so now OH hydroxyl group has been introduced. Now we move on to the step 3. This beta hydroxyacyl-CoA, at the beta position there is a hydroxyl group, acyl-CoA is acted upon by a dehydrogenase. Dehydrogenase also removes hydrogens and then transfers it to an acceptor. Dehydrogenase always have a coenzyme, that is NAD or FAD. Now beta hydroxyacyl-CoA dehydrogenase transfer these hydrogens on to NAD, which becomes NADH plus H plus. So there is a H plus thing. So we come to the step 4 now, because it has removed hydrogens. What has it formed? It has formed a beta ketoacyl-CoA. Now if I remove 2 hydrogens from here and here, what did I get? These electrons are moved, therefore I have got a keto group. That's what I have shown you here. There is a keto group that is formed. So in my step 4, the beta ketoacyl-CoA is acted upon by beta ketothiolase, and there is input of coenzyme A. Thiolases always interact with coenzyme A. Now this coenzyme A, and then it breaks this bond between alpha and beta, therefore this bond is broken down and gives rise to fatty acyl-CoA and acetyl-CoA. The CoA is added on to here, which forms fatty acyl-CoA, and this forms acetyl-CoA. Now you know that these reactions are happening in the mitochondrial matrix. I got a molecule of acetyl-CoA. Acetyl-CoA, you already have learned that, can enter this TCA cycle, and which is also happening in the mitochondrial matrix. Now let us come to the energy yield of one molecule of formic acid. So for your convenience, I have divided this whole board place into activation of fatty acid, which happens in the cytosol, beta oxidation, these 4 steps. You have to remember the various enzymes, they are all very simple, happens in the mitochondrial matrix, in which I got fatty acyl-CoA and acetyl-CoA. Anyway, the reactions of TCA cycle also happens in the mitochondrial matrix itself. Now let's come to the energy yield of one molecule of palmitic acid oxidation. How much ATPs does it give? Because now this can go for another cycle of beta oxidation, but this acetyl-CoA goes for TCA cycle. Now when it goes for another round of beta oxidation, it is short by 2 carbons. These 2 carbons are short, therefore it gets spliced at every time beta position. Therefore that's how 2 carbons are removed as acetyl-CoA. Now a sum total of beta oxidation and TCA cycle for one molecule of palmitic acid, we just learned that one round of beta oxidation gives 1 FADH2 and 1 NADH. So I have 1 FADH2 and 1 NADH. we know that 1 FADH2 is equivalent to 2 ATP and NADH is equivalent to 3 ATP. So now it will go round. Palmitic acid, since it has 16 carbons, it has to splice 2 pieces, therefore it goes 7 cycles and ultimately I get 8 pieces of acetyl-CoA. Acetyl-CoA, when it goes through TCA cycle, one round of it, it gets oxidized into carbon dioxide and water. So now here it generates 12 ATPs. Okay? You learn your TCA cycle, you will know that how you have got 12 ATPs. Now how many pieces of acetyl-CoA I have? I have 8 pieces of acetyl-CoA formed from 16 carbon palmitic acid. Therefore, I have a total of 12 into 8, that is 96 ATPs. When I add the ATPs from here, here and here, I get a total of 131 ATPs. In the first step, now which happened, activation of free fatty acid, this happened in this cytosol. Remember, we used 2 high energy phosphate bonds, therefore I am going to subtract that 2 ATPs from this 131, so I get a total of 129 ATPs. Now coming back, the catabolism of fatty acid has 3 steps. One is activation of fatty acid, then transport of fatty acid loading on to carnitine. Carnitine can pass through the mitochondrial membrane. There is another carnitine there waiting. It forms acetyl-CoA and carnitine is left free. So this acetyl-CoA gets into the mitochondrial matrix and acted upon by 4 enzymatic reactions, in which every time there is this bond making, the position between alpha and beta giving rise to a 1 acetyl-CoA molecule and a fatty acid short by 2 carbons. And we just saw that palmitic acid goes around this beta oxidation process 7 cycles, and how much of ATP has been generated. I hope this video was useful. Please note down all the reactions and the structures. Thank you.